Hello and welcome to another lecture. In this lecture, we are going to discuss about lambda expressions in Java. So lambda expressions are a great feature which was introduced in Java 8. It was a big breakthrough release in which many new features was introduced in Java 8. Along with that, the functional programming constructs was introduced into Java after Java 8. So one of the key functional programming construct is lambda expression. So in this lecture, we will start discussing about lambda expressions. So let's start. So lambda expressions are certain syntax for a code which allows concise representation of implementation of functional interfaces, and it allows us to have reduce the code and represent our functional interfaces implementation in a much more simpler manner. Before lambda expression, we have to use anonymous inner classes and other concepts to implement the functional interfaces. And but lambda expressions provides a very simple syntax in which we will be able to easily declare implement the methods which are present in the functional interface. So what is a functional interface? So functional interface is an interface which consists of a single abstract method. So if an interface has a single abstract method, then that is a functional interface. So you can use the at the rate functional interface annotation to mark the particular interface as functional, and this is how this functional interface will work. And it has a single abstract method, so whenever we want to use that interface, we have to implement that interface is single abstract method. So to do that, we have the syntax of lambda expression. So lambda expressions, let us see the syntax for lambda expressions. So here you can see the left hand side of the lambda expression will be containing the parameters for the lambda, which will be the parameters for our method in the passing in the functional interface. Whatever method is there, that single method's parameter, whatever list is there, we have to supply it to as the lambda's parameter. And the right hand side of the as in after arrow notation, you have to provide after the arrow notation, we have to write the body of the particular functional interface. So like that method we will be able to implement without having much worry. So before that, we have to declare anonymous inner class and we have to implement the particular method. Like that, you have to create the particular implementation of the functional interface. So now it is reduced. In some cases we can reduce the length of the parameter. This syntax also we will discuss when we go through the practical of this lecture. And now let us discuss about some of the advantages of lambda expressions. So lambda expressions, when you create lambda expressions, there will be no class files generated, extra class files are not generated. And so lambda expressions reduces that part of the code, and in the no extra classes are required. And lambda expressions allows reduces the amount of code which we need to write. So it will be we need to just write few lines of code in case of lambda expression. If you use an anonymous inner class or other classes, we have to write more code. So here we can reduce the code amount of code. And the next thing to understand about lambda expressions is it will implement automatically, it will implement the functional interface for us. So that is a great feature to have. So that is about lambda expressions theoretical aspects. Now let us see some practical programs based on lambda expressions. Thank you. Now in this program we will go through the syntax for lambda expression, how we can declare lambda expressions. In this program we will see. So before that, we will have some functional interfaces to write our code to implement our lambda expressions. So let us see the functional interfaces. So here you can see addable is a functional interface which has a single method add, which take two parameters. So that is it about functional interface addable. It is marked with the iterate functional interface annotation. And next interface is incrementer. So incrementer interface has one single method which is increment, which is having a single parameter, and that is it about incremental interface. Now let us see the next interface. So the next interface is printable. So printable interface has a single method print which is not having any parameters. So that is also a functional interface. Now let us see the main method to see the lambda expressions. So here we are in the main method of our program. So first I'm using the creating the lambda expression for the printable functional interface. Here you can see the syntax. In the left hand side of the arrow notation you can see the parenthesis, and in the right hand side of the arrow notation I have provided the implementation of the uh, particular functional interface which I want to implement, method body of the particular function print. So like that we can provide. So here you can see I don't need any braces to cover it if it is in the same line. And next is I am using the method print to call the particular print after getting the object. So next interface is incrementer. The incrementer interface, similarly I am using the another lambda expression to implement the incrementer interface. So here you can see this is a syntax. So here I am using having a single parameter, so at the time you can avoid the parenthesis and directly provide the variable here and then use the particular notation. So this will create the implementation of the increment method. Whatever the body of the increment method is there, that part will write. And that's it about the incrementer interface in implementation. And I'm calling the particular increment method. And after that I am using the addable implementing the addable interface which has two parameters in the particular abstract method, which is add method. So here we can see I am having supplying the parameters for the lambda and followed by the arrow notation of the arrow. After the arrow notation I am writing the body of the particular function interface method, and like that I am adding the particular method, and after that I am calling the sum method. So that's it about this program. Let us see the output. So here we can see all the values are getting printed. The add, the incrementer, and printable. All the method, all the interfaces are working correctly. So this is how we will use lambda expressions in a program. Now let us see another program based on lambda expressions. Now let us see a program based on useful feature about lambda expressions. We will use lambda expression to use a functionality in the comparator interface called as comparing functionality. So we will use the particular method in the comparator interface to see how it is working. So we explained about comparator interface in the arrays and collections lesson. So it is about sorting the data, user defined data, and we will use the comparing method in the comparator interface in this program. So let's start. So here is the object class which I will have the user defined class for this particular implementation. So here is the class employee. It has ID, name, and salary, and constructor is declared, and the toString method is there. So now let us go to the main method. So here you can see the main method of this program. Initial part of the main method, I am adding the employee objects, creating the employee objects, and adding it into an array list one by one. And after that I am using the comparator object. I'm creating a comparator object, and you can see comparator dot comparing of lambda expression I am passing. In this lambda expression I will pass in the particular name. Here you can see I'm not placing any return statement. It will automatically find out the name is a return value, and it automatically returns that value for us. And this is how a syntax for lambda expressions you can use. And here you can see based on name it will sort. So this is the first feature of the comparing method in the comparator interface. Now, after that I am using the sort method and I am passing the comparator object. So that will sort the particular data. Let us see the output of this program. Here you can see the output as came. The values are sorted. The data is sorted with the ascending order of the names. So here you can see it is sorted based on names. So that's it out out of this program. In this lecture, we are covered about lambda expressions in Java, which is a key concept in which was introduced in Java 8, which allows us to implement the functional interfaces with very simple syntax. So here you can understand the syntax. And the important thing to know is that some of the syntax we can reduce it. We cannot we can avoid some parentheses and all. We can reduce the complexity of the lambda expression and make it more easier to understand. So lambda expressions is a key concept we have learned in this lesson. Thank you for watching this lecture. I will be back with the next lecture. Thank you.